So last time when we were talking about horizontal asymptotes, I used the word infinity and I said something else. Look at your notes. I wrote something in each case, and then in one we said infinity something. The limit at infinity. As the value of x goes to infinity or negative infinity, what is the value of y? That would be the horizontal asymptote. In this case, a vertical asymptote is not a limit at infinity, rather it is an infinite limit. Infinite limit in the sense that the value of the function and in math, what letter do we use to denote the value of the function? F of x or y. Right? Y f of x, it would either approach plus infinity, positive infinity, or minus infinity. So an infinite limit is not the same as limit at infinity. Limit at infinity looks at horizontal asymptote, corresponds to x, and infinite limits on the other hand is called 1. At some value. Right. When does a vertical asymptote occur? Now, all this time in algebra, anytime you did divide by 0, the previous professors might have simply said undefined. Yes, it is just a simpler term to refer to a limit, an infinite limit, positive infinity or negative infinity. You know, it is hard to understand the concept of undefined. Imagine throwing words such as asymptotes, limits, infinite limits, all of that in an algebra class. Not much fun. None of you. So technically, it is not undefined. It does have a definition. The definition being it is an infinite limit. Good. Okay. A vertical asymptote will happen at some x, and a horizontal asymptote is an imaginary line that we draw, a horizontal line that we draw along which the curve is going to go. Here, for vertical, so it is an imaginary vertical line along which f of x approaches positive or negative infinity. And when does it happen? It happens it occurs when there are one or more x values that make the denominator 0. What are the examples that we did? 4x squared plus 5 divided by 4x squared plus 7. Is there a value of x, a real number, which would make the denominator 0? The graphs are embedded, so you should know. Is there one? No. There is no real number that is going to make the denominator 0, because no matter what you put for x, it would become positive, positive plus positive, always positive. It's not going to become 0. It's going to happen. That rational function, what is the numerator doing? 2. What is the denominator doing? 2. They are the same. So do you think that it has a horizontal asymptote? Yes. What is it? What is its equation? Like 0. Horizontal. Oh, horizontal. Y equals 4. Why is that, Riley? So the degrees are identical. So we simply divide the numerator coefficient, leading coefficient, by the denominator leading coefficient. 4 divided by 1 is 4. Good. Great. Is there a vertical asymptote? In other words, can you think of numbers that should make the denominator 0? Okay, positive or negative 1. If you plug in +1, 1 squared, -1, 0, parentheses, -1 squared, +1, 1 minus 1, 0. So 2 values at which this particular function will have an asymptote. So at x is equal to 1, at x is equal to -1, the function is either going to go up to positive infinity, to negative infinity, or it could do both. One side go to positive, the other side goes to negative. We will see which is which. Are we clear? So you can type that equation. You have to adjust the window. X values -10. And 4x squared plus 5. Divided by x squared minus 4. and graph. The line fall, and that's the graph we're getting, but it's a bit higher, so I'm going to increase the window range, and I don't need negative. And we may ask, well, is there something in the middle? There is. Any thoughts as to what that value would be? If you plug in x is equal to what? -1 is the denominator. What about the numerator? So finally at the end, you get x5. So there is something in the middle between those 2 points. You're just not able to see it because I got rid of the -1. Oh. When you change it to -10, and see what happens. Yes, that value right there is -5, and it goes down that way. So the horizontal asymptote is along the line y equals 4, right here. And there is a break on this side and that side. If you draw that imaginary line, one would be x is equal to -1, the other x is equal to positive. Good. Oftentimes, when we have a rational function, especially if it has asymptotes, we want to know its domain and range. Sure, you may say, I will sit and solve. We can sit and solve for it. How would you solve and find the places where the denominator will become 0? Set the denominator equal to 0 and solve for x. In this case, if you did that, you are going to get +1 and -1. Great. Look at that picture and tell me what. So look at the picture and tell me what the range is. Range is the set of possible y values. What are all the possible y values? Right? 3, 4, 5. Greater than 4 and less than -5. Do we agree? There is nothing between the horizontal asymptote line, imaginary line, and the point where it turns and it has vertex, which is at -5. So there is no possible value between -5 and 4. How do we specify range in algebra? I asked you to read last time. What do we use? Starts with the letter I. In. Into. Right? So Y. The euro sign means in. What are the possible values? Riley said above 4. So 4. And it keeps on going all the way, shoots up to infinity, so positive infinity. In the other direction, negative infinity, all the way up to -5. I'm writing it in that order because -5 is bigger than negative infinity. Yes? Few things to know. You should never put a close bracket right next to positive or negative infinity. If you see on an exam, a multiple choice question where you have a range and someone has a square bracket by infinity or negative infinity, that's not the answer. Reason being, that is a limit. And last time, the limit is something that you approach but never attain. So it cannot equal that one. So parentheses. What should go right next to four? Parentheses or bracket? Why?
We're never getting to four.
We're going to never get to four because it is a horizontal asymptote. You will get closer and closer to four, but never four. So that's. What about -5? Is it possible to get exactly -5? Alexa says yes. Nolan says yes. If you go back a few minutes, how did we get that -1? I plugged in 0, and when I plugged in 0, I got y to be exactly equal to -5. So that is possible. Good. Let's say you remember your algebra. There are two intervals that we want to bring them together. What should we use? Something's got to go in the middle. A U. What does U stand for? U. Union. Good. This and that. Or that. You're combining them together. Good. What is the domain? Alexa says negative infinity to infinity. Any other answers? Yeah, you know, infinity 1 and negative 1. So we have a curve or negative infinity all the way up to -1. There is a break in the middle. Yes, asymptote, but imaginary line. And then there is that upside down U that is between -1 and 1. And lastly, 1 to infinity. So negative infinity all the way up to -1, -1 to 1, and 1 to infinity. Parentheses or bracket. Okay. How about there, right next to infinity? And how about -1? Should we put parentheses or bracket? Why, Kylie?
Because if it was -1, the denominator would be 0.
So we cannot plug in -1 because that would mean the denominator would exactly become 0. We don't want that. We just want a limit of infinity. So you can't include -1. If you can't do it on the left-hand side, you can't do it on the right-hand side. Same thing for x is equal to 1. Can't do it on the left, can't do it on the right. What should we do in the middle of the gaps? Put the U, and that would be the domain. So There are analytical ways to come up with range and domain without using a calculator. You get to use it in this class, so put it to use.
Is this 3.1,
No,
3.2,
no.
2.5?
For the previous case, we used the calculator, graphed it. We got the range by looking at the graph, yes. And we got the domain by looking at the graph. I want you to do the exact same thing, but with a different function. And right. Okay, give it a try. Ask yourself a few questions. Is there a vertical asymptote? Is there a horizontal asymptote? And then proceed to finding the range and the domain, or vice versa. So what we have here is x squared plus 4x plus 3 divided by x squared plus 5x plus 6. First question to ask is, or are there points where the denominator will become 0? Naturally, we would factor, or we use it for graphic formula. Is it possible to factor the denominator? Yes. X squared plus 5x plus 6. X plus 3 times x plus 2. Agree? Now, two asymptotes. One at negative, one at negative 2. Right backwards. So let's go ahead and enter the function that we have. X squared plus 4x plus 3 divided by x squared plus 5x plus 6. Good. And when we started, we looked at the denominator. I asked you, well, is it possible to factor the denominator? And there it is, yes, we can. I said, sure. We got the two factors, two asymptotes. One would be negative 3, other would be positive and negative 2. So, wrong. There has to be one at negative 3, one at negative 2. Fine. What kind of magic is this? I don't see 2 vertical asymptotes. I only see 1. 1.
Factors cancel out.
Factors cancel out. Anytime you deal with rational functions, do we like fried chicken? Do we like KFC? No? Thank you. I like them occasionally. Think of KFC, even if you don't like fried chicken or KFC, keep, factor, cancel. So should you keep the function as is? Can you factor it? Can you cancel? So keep, factor, cancel. Next time you look at the kernel, pre-calculus. Mind your equals. Okay, so right there before. So if you rewrite, numerator can also be factored. So let's not keep as is, because I can factor x plus 1 times x plus 3. Denominator x plus 3 times x plus 2. What is in common? Gone. The original function was simplified to x plus 1 divided by x plus 2. The numerator degree and the denominator degree are one and the same. So you divide the coefficients, so 1 divided by 1, you get 1. So the horizontal asymptote is y equals 1. And there is only one value where you would have a vertical asymptote. What is that one value? -2. Even though I started with the graph, if someone forced me to do this, I'd love it. But if you want to try KFC followed by this process, I've identified y equals 1 and x equals to -2 as the asymptotes. So I'm going to start by drawing the imaginary lines, the asymptotes. Good. Yes, okay. Okay. The horizontal asymptote is one. The vertical is at x is equal to -2, correct? Now, the function has to move along this line. Agreed? So, is it going along the line? It cannot cross over this way, do you? Because if it crosses over, then you're including those values. This is the asymptote on this side. So that's my code. The next question is, should you draw it this way or should you draw it that way? Yes. Which way is it? How do you know that? Because the count is okay.
There's a vertical asymptote and horizontal asymptote, so it makes like a 90-degree.
Well, there's a 90-degree angle here as well.
Yeah, but like that's, I don't know, it's like not right. I guess.
No, right.
You should plug in 0. It's fine.
So you plug in 0. What do you get when you plug in 0? Let's say hypothetically you drew it this way, right? If you drew it that way, you are saying the lowest value that you can get for y is 1, correct? Are you with me? So hypothetically, we're going to raise this. If you make that your conclusion, the lowest value for y is 1 in limit, but not equal to 1. Agreed? Now plug in x is equal to 0 in the original function. We did the key factor cancel approach, and x plus 1 divided by x plus 2. Yes? Plug in 0. What do you get? 1 over 2, which is 0.5. Well, it is not possible for us to get 0.5 if you suggest that the limiting value is 1. Do you agree? Which means you shouldn't be suggesting that. That's wrong. Because this 1/2 right here is possible. And there is only one way for us to make that happen. What is that one way? That. Yes? Some might wonder, well, oh man, that's bad. That's some might wonder, well, I could cross over and go that way. But that's wrong. Is it a valid point? Instead of drawing it this way, I could have done that. But that is incorrect. Why? Because it can't get over a horizontal passage. This value cannot be part of the function. The moment you draw a solid line going through y equals 1, you're saying that y equals 1 is possible, but in reality, that it's not possible. Good? Now that we have this picture, what are all the possible values for y? Well, all positive values up to 1. Yes. All negative values up to 1 in this side. So I can write the range negative infinity all the way up to 1, 1 up to infinity. What should we put in the middle? And what about the domain? All you have to do is to ask yourself, well, which x value should I eliminate? So real number 9, 0, 1, 2, negative 1, negative 2, negative 3. Which values should not be part of x? Next. Negative 2. You don't have a left at all. You do?
Yeah.
How does that work?
They tried not to, or they copy Lexi.
I see. One of these days, artificial intelligence is going to learn that too. Robots are. Exclude x is equal to negative 2, right? Because that value cannot be put in the function, you get devices. So we've got to exclude that. It can't be a part of the domain. So negative infinity all the way up to negative 2, but it cannot equal negative 2. Negative 2. Where does the line start? Start at negative 2 all the way to positive infinity. Cannot equal that value. What goes in the middle? Good. That's how you do it manually. But in this class, you get to have a calculator, so put it to use. So the domain is negative infinity to negative 2, union negative 2 to infinity.